Hey, so I've been trying to get good at programming in Odin, and one of the things that I have decided to do as part of that is familiarize myself with the core packages that come with Odin. More importantly, not all of them. There's a lot there. There's a lot I probably won't use. But generally speaking, stuff like the FMT package and the operating system packages, I feel like those are things that I'm going to be using in more or less every single project that I create, along with strings. So I've been going through the FMT documentation, just going through and seeing what's in there and trying to use each of the procedures. And every time I do that, I try to use the procedure in some way to get an actual understanding of how to use it and what it does. For the most part, it's quite simple inside FMT. They're mostly related to printing out to the console window, the standard error, or the create some type of allocated string. And I came across the string to enum value and the enum value to string, and I was curious. I wanted to mess around with them, and then I just happened to come up with a little idea for how I might make a small project about them, if you could even call this a project. It's just a few lines of code. Anyways, the idea is I want to have some type of application, and when you use this application, just like every thing in the world, the user, they're going to use it. They're going to put it into different states. In this case, we can have a red state, a blue state, and a green state. And then when the user closes the program, not when it crashes, but when the user closes it, if you run it again, you can see that the application remembers what state it was in before, and it loads up with the proper background color. And to do that, I'm just using an enum value. So what is actually happening is if I print out here, I'll clear the screen so you can see that a little bit better. You see I have a configuration.txt file, and if I was to cut that out, you will see the previous color that the window was is saved into the file. So in this case, it is red. If we open this up one more time, and then I change it back to blue, I close out of it, I'll clear everything again, and then I'll print out the cat file. You can see that it is saved as blue. And I'm using the enumeration value in those two procedures to achieve that effect. So a more substantial use case of this might be if you are programming a video game, you could create save state data. If you have some type of image manipulation program like GIMP or Photoshop, you could remember what project was last opened up as well as what tool they last had selected and load the program up in that current state. But obviously, I didn't go ahead and do anything near enough as complex as that. I just wanted to play around to get an understanding of these two procedures. So I'm just going to run through the code if anybody's interested. And yeah. So I'm using the FMT package, obviously. That's the one I'm trying to use. I'm using the operating system package to actually open a file up and save it. In this case, I'm using OS2. My understanding is that OS was one of the original packages created for Odin, and they kind of used that to do a lot of development. I could be wrong, but I think that's the way it worked. However, the original state of the operating system package wasn't as Bill envisioned, the creator of Odin, and they want to do an overhaul and upgrade it to a different standard. I believe one of the two or three main differences is this original OS package. It uses handles instead of a file type. It uses Boolean values for to give back errors, and I think by default things and anytime you have any allocators you use have default values associated with them, whether that's just the regular allocator or the temporary allocator. I don't know too much about allocators in Odin just yet. I get a gist of what they're doing, but I then believe the big differences in OS2 is you don't use handles, you now get file types. We don't have booleans to get returned for errors, so not true or false. We have a more complex error type and give you more information. And anytime down here where you have some type of information that will be allocated or needs allocating onto the heap, in the previous operating system package, that data was just sort of implicitly allocated for you. You could override that, but you didn't need to. You could just have config.text in here, and then the allocator would have been handled in the background. It already had a default value. I believe I want to say philosophy, methodology, the thought or the thinking behind it is now because this package speaks directly with the operating system. They want you to explicitly say what allocator to use, so you have a more of a sense of how the data in your program is being passed around. I think I'm correct on that one. I could be wrong, but I think that is the general gist of it. Don't take my word for it, though. Go on their website. There are links and stuff on the news articles and more informed people than me, but I believe that is why. So I'm using OS 2 right now because my understanding is sometime early next year, the original operating system package is going to basically be deleted and OS 2 is going to get rolled into it. It's just going to get the 2 knocked off. And then you're essentially just going to have this. But we don't have that right now. So that's why I'm using OS 2. But I am giving it like an alias name of just OS because in the future, I guess that's how it will work. So that's why I'm using the operating system package just to open and read and write to files. I wanted to make a window as an example to save the states. I'm using Raylib. Raylib makes it really easy just to open a window. It's a great little library. And then finally, I'm using the strings function for this function down here, or procedure, I should say, the clone from bytes. So, to actually get into the enumeration part, we have the enumeration that I made. I made a simple enumeration that would let me change the color of the background window, or the background color of the window. And I've just called it colors, and I've given it 3 values, red, green, and blue. And that's all it is. And then immediately the first line of code is I make an object of that enumeration type. I don't give it a default value, which means that the way Odin works with zero initialization is that it's just going to go to the first enumeration value and automatically assign red to it. It's not going to have any garbage data in there. It is going to be red. And then I am coming to read the configuration file. So I don't actually need the configuration file inside of this. So if I was just to remove the configuration text, and then we were to run this program again, you'll see the window will just come up as red because the default value in the enumeration is the color red. Go back into the code. So yeah, if the file doesn't exist, we just get an error saying we can't read the file. And so if error is equal to error.none, I'm not an expert on this new error type yet. I've just kind of realized that if I look for this particular value, I can see if there was an error passed in or not. I need to learn more about how to use this error and read it efficiently. But anyways, the first thing the operating system tries to do is read the entire file from the path config.txt. If the text file is there, it is going to read the only line of text that's inside of it and then pass it into this file. But this particular procedure does not pass me a file type back. It passes me a byte of an array of just bytes. It is just an array of bytes that represent each character within that plain text file. So if I have the color blue, I believe it'll just be BLUE. I don't think it adds any null terminating characters onto the end or anything like that. So I believe that is all it is. And then finally, I go to file color, and what I want to make an actual string out of these bytes of data because Odin does not implicitly convert stuff. You need to explicitly tell Odin when you want one data type to be transformed into another. And I need to pass a string into this strings to enum value procedure. So the way I'm getting the string is I'm using the strings package. Inside of the strings package, there is a clone from bytes. And all that does is it takes in the raw bytes that I have, looks at them, and then turns them into whatever Unicode characters happen to be in there. In this case, it will just be plain ASCII text. So it'll be the first 0 to 255 characters in Unicode. Because I think strings in Odin are UTF-8 encoded. And yeah. So then I check to see if there is an error. If an error hasn't occurred, so it did read the file, what we then do is we get our enumeration object. We then ignore the error value that can be passed out from this. I figured if it gets to this point, there's not going to be an error. And then I just say fmt, so the format package, strings to enumeration value. And to use this procedure, I take the enumeration type, not an object of enumeration, but I take the actual type name that I've created. I pass that in as my first procedure, first parameter. And then I pass in the string, which we turned up here. We got the string from strings.clone. I pass in that value, and then it reads the string, and then it looks at the enumeration type, and it sees if there is a enumeration value that matches that string in here. So my understanding is if this does error out because of zero initialization, it can pass an error value back to you. But the worst case scenario is this will be set to its default 0 value. So if this procedure was to fail, it will then it will then default back to red. We can actually test that out. So if I was just to delete this word, and then I just pass in some garbage string here that does not exist in the enumeration value. And the configuration file should exist still because we just made it. So no, it doesn't. Right, so if we just quickly, I'll just quickly make that. So echo, let's pass blue into the config.txt file. That's what I called it. We now have the config file. And then we were to try to run Odin. What you would expect, because the word blue is in there, is the screen should show up blue. But because we messed around with that string in the code, it should show up red. So there we go. If that procedure does fail, nothing actually crashes, but you do end up just falling back on whatever the default value inside of your enumeration type would be. How did I spell that wrong? Did I spell that wrong? Nvim. Am I? I can't spell. There we go. So yeah, if this fails, it is okay. Well, it might not be okay. You know, having an enumeration value mess up could break your entire program later on down the line. But this will not cause your program to crash if it does fail. It will just default your enumeration object back to whatever the zero value is. I was just doing this for debugging reasons. I can get rid of this line of code now. And then finally, I'm opening up the Raylib window, and then I'm making a loop. Just the main game loop for Raylib, or the main window loop. This isn't actually a game. And to get the input from the user, I'm just saying Raylib use is keys pressed. So Raylib has a very nice user interface, or application interface, I should say, API. And inside of that API, there is an enumeration. I think it is called keyboard. And the way Odin works, it seems to be smart enough. If a procedure is expecting a certain enumeration object to be passed inside of it, you don't have to give the full enumeration name. You don't have to go, oh, is colors.blah, is colors.green, is keyboard.red, is keyboard.b. You can just do the dot and then the actual enumeration value. And Odin seems to be smart enough, or at least Odin's compiler is smart enough to infer, I can see the enumeration object, so I'm just going to check inside of that and look, does this value exist? So that's why I can get away with just putting .r, g, or b there. And you can see the same thing down here in the switch statements. You can say I just do .red, .blue, .green, because Odin knows that I'm working with a color type up here, and it knows I'm working with a keyboard type or key type. I forget what the actual enum is called inside of the Raylib package. And then if it does detect that I pressed R, we set the enumeration color object here to be red or green or blue, and then we begin drawing. We have a switch statement in between the beginning and end, and all that's looking as if it is set to red, green, or blue. We just clear the background using Raylib's default colors that it comes with, or constant colors. And this will just loop through infinitely. And at this point, if you were to close the program by pressing escape, as every Raylib window opens up with the ability to already just press escape and close. And I'm not sure where, I don't think that is Raylib itself. I think under the hood, Raylib is a wrapper around OpenGL, and I am pretty sure it is using GLFW. And if I remember correctly, when I tried to learn graphics programming a while ago, but I never got that far into it, I think GLFW was kind of a nice abstraction, a nice interface just to open a window on any operating system. It hides away the technical details, so if you want an application to open a window on Windows, on Linux, or on Mac, you can use GLFW, and that will just handle opening the window for you. It will check what operating system you're running. And I believe GLFW itself handles the closing of the window, so you can just press escape on GLFW. So I don't think that is actual functionality implemented by Raylib. I think it's just the wrapper over GLFW. Yeah, I think that's how it works. Again, could be wrong. I really don't know any graphics APIs near enough to speak too truly about it. And then finally, if the user does press escape, the window closes before the application just all finishes. We have a few lines of code down here. I have the string that I want to actually save into the file, and that's why I'm using the fmt enumeration value toString. I'm passing in our enumeration object, which will either be of .red, .blue, or .green. And then this procedure simply looks at the object we've passed in, and it looks at its value, and then it will turn this into whatever the value is. So red, it will just turn that into a straight UTF-8 encoded string. And yeah, it will just pass it back into this string there. And I'm using os.create to make the configuration file. The reason I'm using create is I want to just overwrite the file each and every time. I don't want to append to it and add to it. Maybe in a more sophisticated application, you wouldn't want to rewrite the entire file. You would just want to jump to the section that you're actually editing and go replace these values. But because this is such a small little demonstration, I figure just making the file over and over again. So os create, what it does is it will first check, does the file exist? If the file doesn't exist, then it creates the file. If the file does already exist, it essentially just takes the file, deletes all the text inside of it, and then starts writing again. So whatever the case is, the file does exist or it doesn't exist, you essentially end up with a new version of the text file. And then I'm simply doing os.writeString, and then I pass in the configuration file. This create function is one of the OS2 procedures, and this one does pass back the new file type. It doesn't pass a handle. And then the other thing it just needs the string that I'm going to pass into it, and that is the string we got from enum value to string. And then it will either write red, green, or blue into the text file. And then up here, if the configuration file doesn't exist the first time, we default to red. But as we fall back down the first time around, the text file is then created. So as the program opens up again, it will actually find the config text file, and then it will be able to read it, and it will be able to read the red, green, or blue text that's inside of it. And that essentially gives us the, I do not want to put Z's there. That will essentially give us the functionality that we have right now. Odin run dot, and then as I showed in the beginning of the video, I can now change the state of my program because the configuration file is being created. It, remembers. The program doesn't actually remember, the file does. It just reads the file. But yeah, that was just my little demonstration. Hopefully somebody found it useful to learn. Personally, the reason I'm making these videos again is earlier on this year, I used to make these little YouTube videos because they helped me a lot in terms of learning and understanding by having to explain what I have done. Is it Richard Feynman? I think it's called the technique where you try to teach something back to someone. So it really helps me. It also helps interact with other people who know more than me. There's cases when I used to make these videos. This is a brand new YouTube channel now, where I did, and occasionally somebody say you're wrong, and that's great because somebody was able to highlight an area in which, oh, I was actually wrong here, and you learn. And also, I took a big step back from social media and just everything. I deleted everything: Steam, Facebook, Instagram. What other social media did I use? LinkedIn? Did I use LinkedIn? Anyways, any social media I did have, I just got rid of. Same with YouTube, deleted my YouTube channel, stopped it. Just to figure out what do I actually miss and what do I need in my life to be happy. Turns out not a lot, but one thing I did miss was making these YouTube videos as a form of just learning and understanding. So yeah, that was my little demonstration. Again, this was more for my own benefit, my own learning, just iterating over what I've already learned and done. If you did learn something and you've watched this far, that is great. Thank you. And if you do find any errors or you say like, hey, you're doing your strings wrong, feel free to leave a comment. I will not be annoyed. I'll happily learn from people. I'll see you in the next one.